Okay, we are working from the Course 2 textbook. You do not have this textbook, but you do have access to this through Big Ideas Online. So we're working in the Course 2 textbook. We are doing lesson 5.2, which can be found on pages 173 to 174. And we're going to be talking about proportional relationships. Proportional relationships is also equivalent fractions. So if something is proportional, it's also an equivalent fraction. And there's three ways to determine proportionality. Are they proportional or not? So let's go over that. So do 6/4 and 8/12 form a proportion? Do 6/4 and 8/12 form a proportion? There are three ways that we can use to figure out if they form a proportion. And it's good to know all three ways because some problems lend themselves more towards one way or than another. So it's good to know all three ways. So the first way to determine if two fractions are proportional is to reduce the fractions. So 6/4 divided by 2/2 equals 3/2. That cannot be reduced any further. 8/12 can be reduced by 4/4, which gives us 2/3. 3/2 most definitely is not equal to 2/3. So it is not proportional. Not proportional. A second way to do this is it's two things. We're going to set it to 1. We're going to set the fraction to 1, but it's also turning it into a decimal. Turn into a decimal. So when we turn something into a decimal, when we turn a fraction into a decimal, it's the same thing as setting it to 1. So what does that mean? Well, 6 divided by 4 is equal to 1.5. So 6 divided by 4 is equal to 1.5. 8 divided by 12 is equal to 0.66. So we're setting these to 1 or turning them into the decimals. It's the same thing. 1.5 is not equal to 0.66. So not proportional. And the third way of doing this would be to cross multiply. Cross multiply. 6/4, 8/12. Is 6/4 equal to 8/12? I don't know. Let's cross multiply. 6 times 12 is 72. And 4 times 8 is 32. 72 is most definitely not equal to 32. So not proportional. So when they're asking if two fractions are proportional, do they form a proportion? We have three ways that we can use to figure that out. We can reduce the fractions. We can set the fraction to 1 or turn it into a decimal. It's the same thing. Set the fraction to 1 or turn it into a decimal. Or we can cross multiply. All three of these can be used to determine whether numbers are proportional or not. And it's good to know all three because sometimes it makes sense to reduce or to turn something into a decimal, but not cross multiply. And sometimes it makes sense to cross multiply. It's easier to cross multiply than it is to reduce. So it's good to know all three methods. So let's do another one. Does the ratio form a proportion? Does the ratio form a proportion? 25/20ths and 15/12ths. Does the ratio form a proportion? Well, let's reduce. So 25/20ths can be reduced by 5/5 equals 5/4. 15/12ths can be reduced by 3/3. And would you look at that? 5/4 most definitely equals 5/4. It is proportional. It does form a proportion. So here we can set to 1 or turn it into a decimal. Find the decimal. So 25 divided by 20. Can you use a calculator for this? Yes. 25 divided by 20 is 1.25. 15 divided by 12, would you look at that, is also 1.25. So 1.25 is most definitely equal to 1.25. It is proportional. And then we have our handy dandy cross multiply. 25/20. We want to know if it's equal to or proportional to 15/12ths. So let's cross multiply. 25 times 12 is 300. And 20 times 15 is 300. Can you use a calculator? Yes, please do. 300 is equal to 300. It is proportional. So you can use any one of these three methods to determine whether fractions are proportional or not. Reduce, setting to 1 or turning it into a decimal, or cross multiplying. Okay. Okay. Now, the book gives us a table that looks like this. XY. 1/2 to 3. 1 to 6. 3/2 to 9. And 2 to 12. So they give us this table and they ask us, are X and Y proportional? Are X and Y proportional? Okay. The first thing I'm going to do, I'm going to turn my X and Y's into fractions. 1/2 over 3, 1 over 6, X over Y, X over Y. So if I wanted to, when I look at this, the ways that make sense to me would be either to reduce fractions or turn them into decimals. Both of those ways make more sense than cross multiplying. Because if we cross multiply, then we have to cross multiply these two, cross multiply these two, cross multiply these two, cross multiply these, and then these. That's an awful lot of work. So I can use cross multiplication. It's just a lot of work. When I look at this problem, to me, reducing the fractions or turning them into decimals makes more sense. So how about if we reduce our fractions? So my first one is 1/2 over 3. Uh-oh. This is like a fraction in a fraction. That's a mess. So technically, we're not going to reduce it. We're going to multiply it by 2 over 2 so that I have clean numbers to work with. 1/2 times 2 is 1, and 3 times 2 is 6. This fraction is much easier to work with. And then 1/6 is 1/6. 3/2 divided by 9. I need to get rid of this fraction. So to do that, I'm going to multiply, here's my denominator, by 2 over 2. This is going to give me 3/18, which is 1/6. And then I have 2/12. Reduces to 1/6. Holy smokes. When I look at all three of my reduced fractions, they all equal 1/6. This is proportional. Now we have our second way. We can set to 1 or turn into a decimal. So I have 1/2 divided by 3. So I'm going to 1/2 is 0.5 divided by 3 is equal to 0.16. And that 6 goes on forever. 1 divided by 6 is 1/16. That 6 goes on forever. 3/2 divided by 9. Well, 3/2 is 1.5 divided by 9 is equal to 0.16. That 6 goes on forever. And then we have 2 divided by 12. Would you look at that? All of my decimals are the same. It is proportional. Now, can you use a calculator for this? Yes, please do. It makes sense. Okay. So when we're given a table, sometimes it's easier just to reduce or turn into a decimal rather than cross multiplying. Cross multiplying could be a lot of work. Okay, let's take a look at our last problem. Let's take a look. So we have this problem right here. You swim your first 4 laps in 2.4 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? I don't know. Let's find out. The first thing I'm going to do is turn this into a fraction. I want my time over my laps. Now, somebody asked me, how do you know which goes on top, time or laps? How do you know which goes on top? It doesn't matter. It doesn't matter. If you have time over laps or laps over time, If as long as you're consistent, if they're proportional, it will show. So my time was 2.4 minutes for 4 laps. Is this proportional to 12 minutes for 16 laps? And if you had flipped it lap over time, that's okay. It's okay. So the first thing, let's reduce 2.4 over 4. Well, I can leave it like that, I guess, or I can reduce by 4, which is going to be 0.6 over 1. I'm not sure which I'm going to need, so let's see. 12 divided by 16. We can reduce this by 4 over 4 and get 3/4. So if I'm looking reduced, this is not equal to this. But if I want a common denominator, typically we need common denominators to compare fractions. This is most definitely not equal to this. So it doesn't look like these are proportional. So it looks to be not proportional. But let's make sure. We can set to 1 or turn into a fraction. I mean decimal, same thing. Turn into a decimal. So 2.4 divided by 4, 0.6. 12 divided by 16 is 0.75. 0.6 is not equal to 0.75. Not proportional. And we have our handy dandy cross multiply method. 2.4 over 4. Is that equal to 12/16? I don't know. Let's cross multiply. 2.4 times 16. Can you use a calculator for this? Yes, please do. 38.4. 4 times 12. 48. 38.4 is most definitely not equal to 48. So, not proportional. So we're working on proportional relationships, and basically a proportional relationship is an equal fraction, equivalent fractions. So we can reduce to see if we can find equivalent fractions. We can turn them into decimals or set them to 1, or we can cross multiply. We have 3 different methods to determine whether 2 numbers are proportional or not.